So for our number 2, we have the integral of square root of 2ax minus x squared dx. So first thing we need to do, we have to expand this expression right here. So it will be like this. So it will be integral of square root of a squared minus quantity x minus a squared dx. And then after we have expanded this one, we will now apply the u substitution. So let u be x minus a, since we have the expression that is in the parenthesis as it is stated in our u substitution rule, that we can, anything that can be substituted once it is under the parenthesis or inside the parenthesis rather. So the derivative of this one will be dx. And then next we will now apply the u and du in here. So we will have this one as our outcome. So this will be u, then we have squared, so we have squared here. And then we will now apply the trigonometric substitution, since we have the expression a squared minus u squared, so we will use sine. So u is equals to a sine v, then its derivative will be a cos v dv. So we will now solve for this one. So for this one, we will now substitute it to the expression here. So a squared minus, for u we have a squared sine squared v, then its du will be a cos v dv. And then right here, so based on the rule of sine squared v, we know that sine squared so based on here, we will turn it into 1 minus sine squared v. Okay, so next we will now turn into this one. So based on the trigonometric identities that we know, 1 minus sine squared will equate to cos sine squared v. So a squared plus cos sine squared v, then a cos v. And then next we will take the constant. So we know that a squared is the constant here, so we will take the constant out, then write the remaining values here. So integral of cos sine squared v dv. So using the trigonometric identities of cosine squared v, so we have 1 plus cosine 2v over 2. So we will now find its antiderivative. So we have here 1 plus cosine 2v over 2 dv, its integral, and then we will now take its constant. So we all know that this whole expression here is 1/2, so we will take that 1/2 out, and then the integral of the remaining values here, so 1 plus cosine 2v dv, and then we will now separate it. So 1/2 integral of 1 dv plus cosine 2v dv. So in finding its integral or antiderivative, we will have here, it will become v, then the cosine 2v dv will be 1/2 sine 2v plus c, and then we will just combine it, and then we will have our answer here. So copy a squared, then multiply it to this antiderivatives here. So we will now have its answer here.